Hi students, we're going to use the dot product to find angle between vectors. So it would be two vectors like this. They're sort of offset from the initial side, and I actually need to find the angle between their terminal sides. So the formula for this is that the cosine of theta is equal to the dot product of those two rays or vectors divided by the product when you multiply the magnitude of those two vectors. So this is actually a derivation or deriving from the law of cosines, which we haven't really covered at all. So I don't want to try to prove this to you. You wouldn't be happy. So here we go. Let's not do this one because they've already done it. Let me put another problem up here. Okay, so here we go. Here's our two vectors, and we're going to try to find the angle between them. So first, step one is find the dot products of the vectors. And when I do that, that's going to give me the numerator. So 15 times negative 5 is negative 75, plus 45 times 12, 45 times 10 is 450, and then 90 more is going to be 540. Okay, so that's going to give me 465. Okay, now I'm going to find that's my numerator. Let me take it down here, 465. Now to find the denominator, I'm going to find the magnitude of this. So remember, I just square the a. The magnitude is like, square this, and find the square root of the sum that you get. So if I square 15, I get 225. If I square 45, 4 times 5 is 20, it's going to be 2025. There's a little trick to squaring anything that ends in a 5 that I'll show you if you want me to. So what is that? 2250. Now it's the square root of that. Okay, so I've done the first one. Now let's find this magnitude. So 5 squared is 25, and 12 squared is 144. That gives me 169, but the square root of 169 is 13. So I get to simplify that one. That means the denominator is going to be the square root of 2250. So I'm going to put in 2250, and I raise it to the half power because that's the same thing as the square root of, times 13, and I get 616.64. Now I'm going to divide the top by the bottom to give myself a number I can work with. And it's 0.7395 if I clicked everything correctly. Okay, so now that has to be multiplied because I have the measurements of those two sides, the ratio of this side to this one, and I know that it's not a right triangle, but the law of cosines works anyway with that. So I'm going to take inverse cos, the second cos, which some people call the arc cos, 7.395, and I get 42.31. So that angle between them is 42.31 degrees, and that gives me the angle between them. Now let me make a distinction. If you had, let me give you a problem like that. Okay, these two I put in the IJ thing. If I find the dot product at the top, 8 times negative 2 is negative 16, and I add 4 times negative 1 is negative 4, I get negative 20, right? Okay. Sorry, that's negative. So that's my numerator, negative 20. Now for the denominator, 8 times 8 is 64 plus 16. That is square root of 80, which that is 4 root 5, right? And then 4 plus 1 is square root of 5. So look at this. At the bottom, I'm getting 4 times 5 is 20. So I'm getting negative 20 over 20, which is negative 1. Here's the problem, guys. If you ever get negative 1 or positive 1 as your when you do this, you have parallel lines, which I should have noticed. Because look, these are proportional. If I multiply 2 by -4, I get 8. 1 by -4, I get 4. I'm sorry, -1 times -4. So these are proportional to one another. In other words, if I took -8 divided by -2, I get -4. 4 divided by -1, I get -4. They are parallel. So I'm not going to get anything. But if I get this far and I don't realize I have parallels by looking at them. Once I get that -1 or that 1, I realize I do. Now, by the way, if you get a 0, if you ever get a 0, it's because you have something that's at right angles. They're orthogonal. So if you get 0 in this calculation, or you get -1 or 1, you have a problem. So nothing to be scary about, right? Surprise. Had to do that for my third period. Okay, you guys take care.